Hi guys, how's it going? So today we're going to be looking at this question. I pretty much like it. So it's called a single element in a sorted array. So we are told that we're given a sorted array consists of only integers where every element appears exactly twice, except for one element which appears exactly once. So we need to return a single element that appears exactly once. So for instance, what they're saying is that all these elements are going to appear twice, but there's going to be one element that appears once, which is in this case is 2. For example, 1 1 appears twice, 3 3 appears twice, 4 4 appears twice, 8 8 appears twice. But there is a catch. We are told that we need to solve this in of and log n. So they want a very fast algorithm, and the space should be O for 1, right? So we know that, okay, we don't have to think along the lines of brute force. So we know that we need to use a binary search, right? But even if you're using a binary search, how would we then tackle this problem, right? Um, so how would we tackle it is that we're gonna leverage the technique of even and odd. So by even and odd, what I'm saying is that we can see that these values, because they are next to each other, the values that are appearing twice, they're next to each other. So we can know that, okay, this one is odd, right? This one is even, right? This one is even. This one is odd. So you can see that 2, yes, it's odd, but it does not have even. So which means that here, this guy 2, that means it's appearing alone, right? Because everything's supposed to have odd and even, odd and even, odd and even. So that's the technique that we're gonna leverage, right? So from a binary search perspective, the first thing that we're gonna do, because we're gonna start at the mid right at some point. So the first thing that we're gonna do is that we're gonna say when we get to the midpoint, we look on the left and we look on the right. The reason we're doing this is because we want to check if these values are the same with the mid. And if none of these values are the same with the mid, that means the mid is the single value. For example, let's do this. Let's say we have 1 1 and we have 2, right? We have 3 3. So you know how binary search work, right? So we start at the mid. So we look at, okay, is the left same to the mid? No, it's not. Is the right same to the mid? No, it's not. Then mid must be the single guy. Yes, it is, because it does not have a match. We know that these they have to appear next to each other, so 2 does not have a match anyway. Now, coming to our second case, right? How do we then, my second question to you is that, how do we then get the low and high? You know how binary search work, right? So how do we get low and high to kind of like low, low plus mid or something like that, low equals to mid minus 1, or high, something like that. So how do we shift these mid and high, right? So that will be my next question. So how we're gonna shift them so that we can look on the other side, on the other half, is we're gonna leverage the even, the concept that I explained to you now, the even and odd. So what we're gonna do is that we can imagine that let's say this tray here, it's the mid value. So what we do is that we take the mid value, right, and we divide this, we take the modular, right, and if the modular equals to 0, then we know that, okay, this is supposed to be an even. And when it's even, yes, when it's even, like I said, we have odd, even, odd, even. So when you're on odd, right, when you're on odd, where do you look? You look to the left, right, because of, you're gonna find the same guy, right? When you're on odd, yes, this is odd again. Where do you look? You look on the right, because you're gonna find your match. When you're on odd, yes, you're on odd. Where do you look? You look to your right, because you're gonna find your match. When you're on odd, where do you look? You look to the right, because you're going to find your match. When you're on even, where do you look? You look to the left because you're going to find your match. When you're on even, you're going to look to the left, right? You get this. You get this. You get this. So what we do is that we check if the mate is definitely even, and when it's even, where do we look? We know that we look to the left. So we're going to say mate, we're going to take nums, and we take mate to the current mate value, and we're going to ask if is this equals to nums mate minus 1, and that's what we're going to write. And if we know that they are the same, definitely they're the same, that means everything from here it's fine. Definitely we don't have to look that side. That means the low is gonna be low equals to mid plus 1, right? But this is a thing. What happens when this is not true? What happens that, let's say I was showing you this example, let's say 1 1 2 2, and we have 3, we have 4, we have 4. What happens when what is this? You have odd, even, you have odd. So when you have odd, we said that you look to the right? But what happened when you have odd and you look to the right and you're expecting to see 3, but you don't find 3, right? You know that, okay, cool, something's wrong on the side, like something is definitely wrong. So you're gonna shift to your high instead of your low. That's the idea. So that's the algorithm that we're gonna write here, right? So yeah, so it's gonna be an if else statement. But I hope this is the high level idea. I'll try to code it up and explain each line of code. Maybe this was quite confusing a little bit. Maybe on the code you guys are gonna have a better context. But yeah, I think it's just like the main idea is like the even and odd, and yeah, I think that's like the main idea for this, and using a binary search obviously. But yeah, let's code it up and see how far we can get. Okay, so we're just gonna call this so with our binary search we need low and high. So our low is gonna be 0 and our high is just gonna be, we're gonna take the length. I think we're given the nums, so we're gonna say length nums is gonna be -1. Let's handle all the edge cases. So we're gonna call this boundaries. So I'm just gonna write boundaries. So what we're gonna do is that we're gonna check if high, right, equals to 0. So we're just gonna say that means there's a single element. So we're just gonna say return nums 0, right? So handling all these edge cases. The second edge case is around the first element and the last element. So if it happens that this first element does not match the second element, that means the first element is our answer. So it's gonna be if nums, right? It's gonna be 0 and it's not equals to nums, then this is gonna be 1. Then I'm just gonna make sure that I return the first nums. So this is just to make sure that when we go to our binary search, we're going with like at least we have handled these edge cases. Okay, so we're gonna do the same thing that we just did now, but now on the high element or the last element. So it's gonna be high, and if high is not equal to the previous element, which is nums, we're just gonna say nums, and I'm just gonna say high minus 1. Then what I do is that I just have to return nums high. Okay, I think here I have high, this is fine, this is high minus 1, this is okay. Okay, cool. Then I just need to make sure that my low does not flip with the high. So just to maintain that, I'm just gonna, so while low is less than or equals to high, and I'm just gonna get my mate by taking the low plus high and making sure that I do an integer division. Yep. Then what I'm gonna do is that I'm gonna start with the first condition whereby we said that if we get to the mid, we look at the left and the right to see if like none of them are the same with the mid, then we know that the mid is the correct answer. So what we're gonna do is that we're gonna ask ourselves if the current mid is actually not equals to nums, then I'm just gonna look back of mid. So you see, that's the thing I like. So we don't have to check a lot of edge cases because we know that we did check them here. So we know that if we say something like mid -1, has to be a previous value because we did check here. So yeah, in case you're wondering about edge cases. So we're gonna say nums, then we say mid. Now we're gonna have to look forward. So we're gonna say if the current mid number is not equals to nums, we're gonna say mid +1. Okay, then what we do is that we're just gonna return nums, we get mid. So now this is the logic where we must pay attention. So remember that with Python, we start to index at 0, 1, 2, 3, right? So which means that essentially we're gonna swap the even and odd, right? Because of we're using an integer. So remember that we said that when I was doing an example, we said 1 is odd, 2 is even, but because of we're using an integer, because of we're using an integer, right? So we start at 0. So essentially this is gonna become our even and this is gonna become our odd. So just keep that in mind. So what I'm gonna do is gonna say even, gonna say mid divide by 2, then modular 2 I meant to say, then just gonna say if this is equals to 0, and I'm just gonna say nums, I'm gonna take mid, then equals to nums mid. So I was saying that because I didn't want you to be confused around here and say, oh, but you said that with even you're supposed to look back, right? Because it's 1, it's like 1 and 2. So when you're here, if this is even, you look back to your odd. But then why do you add 1 here? Like I said, that is because of with Python or programming languages, we index at 0 and 1. So hence we doing that. So you can imagine that we have this. So you see here, this is going to be our even. So you're going to have to look at where? You're going to have to look forward. You're going to have to look here. So because this is going to be even, so you look forward. So you see, so that's why here I'm saying mid +1, right? So I don't want you to get confused there because of these indexes, okay? So just keep that in mind. But anyway, so we're gonna say mid modular 2. And what we do, so say equals to 1. So now we're checking for odd, and now we're just gonna say and mid. Then we go back, right? We look back, we say mid -1. Yes, we do that. So if this is that, then we're just gonna make sure that we just move our mid now +1. So does this make sense? Does this make sense? Yes, it does, because what we're checking here is that if we remember that if we have let's take an example. Let's say we have 1, 2. I'm just writing indexes. So let's say that we here on 2, né? We here on 2. So this condition is gonna be true because we're here. Then we look on the right. Yes, we look on the right and we find that the value on the right, it's matching. So that means that this side and on the left side everything is fine. So we should look definitely on the right side. So we should look these values that are on the other side. because these ones look like they're following the right order. Yes, they're following the right order. Remember that here it will be 1 1, here it will be 2 2, and then when we're here we look on the right side, we see that okay, we have 2. That means these values here are following the right order, so we need to look on the side if they were not following the right order. So you can imagine that they were gonna get shifted, so you're gonna have something like this. So you are gonna get something like this. So when you get something like this, you're gonna say 2, then you look on the on the right side, you see that there is 3. That means there's something wrong here. That means you have to look on the side to find the value that is actually, and you're gonna find it at all, it's 1. So yeah, that's how I kind of like think about it, right? I hope it does not confuse you guys. I try my best to explain as much as possible. I try to make sure that you understand. So now guys, we are done. We just need to make sure that if it happens that the low and the high pass one another, or that statement is not true, we're just gonna return -1. Yeah, we're just gonna return -1. I'm just gonna run this and see how far we can get. Oh no, did I make a mistake? There's always mistakes, so if this is supposed to be equals to, I think there's another mistake. I knew it. So it says what? Nums. Okay, this, these bugs. Yeah, typos, and it works. So yeah, guys, that was it. We solved this in login because we used the binary search algorithm, and we can see that this is 96%, so it's very fast algorithm overall. So yeah guys, thank you very much for tuning in. I really hope you enjoyed this one. I'll see you in the next one. Bye.